What if our world is not real? Take a moment. Look around you. You see the walls of your room, the light from your screen, the sky outside your window. It all feels solid. It all feels real. But what if it isn't? Everything you've ever known, everyone you've ever loved, every star you've ever wished upon, is simply part of an incredibly advanced computer program? This isn't a question from a science fiction movie. It's a question that philosophers and scientists are seriously asking. It's a thought experiment that stretches the very fabric of what we call reality. It invites us to be cosmic detectives searching for clues in the world around us. This idea might sound strange, it might even sound a little scary, but curiosity is the engine of discovery. We once thought the Earth was the center of the universe. We once believed the stars were just tiny lights fixed to a celestial sphere. Every great leap in our understanding began with a bold question that challenged what we held to be true. So, let's be bold. Let's ask the question, are we living inside a grand simulation, created by a civilization far more advanced than our own? The journey to explore this possibility is a journey into the heart of physics, philosophy, the nature of consciousness itself. It's a quest to understand our place in the cosmos. To understand this cosmic question, we first need to understand a simple word: simulation. What is it? A simulation is a copy. It's a model of a real-world thing or process run on a computer. Think about a pilot learning to fly. Before they ever step into a real airplane, they spend hours in a flight simulator. This simulator mimics everything about flying: the controls, the weather, the feeling of turbulence. It's a safe, controlled digital copy of reality. It allows the pilot to practice, to make mistakes, and to learn without real-world consequences. The simulator isn't the real sky, but for the person inside, it can feel incredibly close. We use simulations all the time, and they are getting better every day. Scientists use them to model climate change, predicting how our planet's weather will shift over decades. Engineers use them to test the crash safety of a new car before a single piece of metal is ever built. Economists use them to forecast how a new policy might affect the market. In each case, we are creating a digital twin of a system. We input the rules, the laws of physics, the principles of economics, and then we press run to see what happens. These simulations are our crystal balls, powered by mathematics and code. Now, let's expand that idea. Imagine a simulation not just of a car or the weather, but of an entire ecosystem. You could model every plant, every insect, every animal. You could program the rules of evolution, natural selection. Then you could fast-forward time, watching how life evolves over millions of virtual years. We are already doing this on a small scale. We create artificial life, simple digital organisms that compete, reproduce inside a computer. They are not alive in the biological sense, but they follow the basic principles of life. What if you just kept scaling that up? This is the key. A simulation is a constructed reality that operates according to a set of predefined rules. The reality inside the simulation can be incredibly rich and complex. The beings within it might never perceive the underlying code that governs their existence. They would simply call those rules the laws of nature, the laws of physics. Their world would feel completely real to them, because it's the only world they've ever known. The question for us then is whether our laws of physics are the ultimate rules, or if they are just the programming for our particular level of reality. So where did this wild idea that we are living in a computer program come from? It's a modern twist on a very old philosophical question. For thousands of years, thinkers have wondered about the nature of reality. The ancient Greek philosopher Plato, in his famous Allegory of the Cave, imagined prisoners who have spent their entire lives chained up watching shadows on a wall. They believe these shadows are reality, never knowing about the real world outside causing them. This was an early attempt to question whether what we perceive with our senses is the full picture. It's the seed of the simulation hypothesis. The idea took on a more modern technological form as computers became more powerful. In 2003, a philosopher at Oxford named Nick Bostrom published a groundbreaking paper. It was called, "Are You Living in a Computer Simulation?" He didn't just ask the question, he used logic to argue that it's actually quite likely. His argument is a kind of cosmic bet. It goes something like this. If a civilization can survive long enough to develop technology that can create conscious, simulated worlds, what he calls ancestor simulations, they would likely run many of them. Think of it like a historical research project on a cosmic scale. Bostrom's logic is powerful. He presents three possibilities. 1. Civilizations like ours almost always go extinct before they can build ancestor sim tech. 2. Advanced civilizations that can run these simulations choose not to, for ethical or practical reasons. 3. We are almost certainly living in a simulation. The most famous example is the 1999 film, The Matrix. In The Matrix, Neo discovers his entire life has been a lie. The late 20th century world he knows is actually a sophisticated virtual reality. Humanity is trapped inside this digital dream, serving as a power source for intelligent machines in a desolate real world. The movie brought the simulation hypothesis into popular culture. It gave us iconic images. Cascading green code, the red pill of truth, the blue pill of ignorance. It made millions walk out asking, what if? But the idea goes back further. In his 1959 novel Time Out of Joint, Philip K. Dick wrote about a man who slowly realizes his idyllic 1950s town is an elaborate fake. Dick was obsessed with the nature of reality. His stories question what is real and what is manufactured. Another example is The Truman Show. A man's entire life is a TV show broadcast to the world. Everyone he knows is an actor, his town is a giant set. He doesn't know it, but subtle glitches lead him to the truth. So, let's say it's true. Let's say we wake up tomorrow and there's definitive proof. We are living in a simulation. What would change? In one sense, absolutely nothing, and in another sense, everything. Your morning coffee would still smell the same. The laws of gravity would still keep you firmly on the ground. Your love for your family and friends would still feel just as real. As with any grand idea, the simulation hypothesis has its share of both passionate believers and staunch skeptics. The debate is a healthy and essential part of the scientific process. It pushes both sides to find better evidence and refine their arguments. The believers, as we've seen, point to the mathematical nature of our universe, the strange rules of quantum mechanics. The statistical argument from Nick Bostrom. They argue that to deny the possibility of being in a simulation is to assume that we are the pinnacle of creation, the one real universe among a potential sea of fakes. On the other side of the cosmic aisle are the skeptics. They raise some very important and difficult questions for the simulationists. One of the main arguments against the hypothesis is that it's fundamentally untestable. A good scientific theory must be falsifiable. There must be an experiment you could perform that could prove it wrong. But how could you ever prove you're not in a simulation? A perfect simulation would, by definition, be indistinguishable from reality. Any evidence you find could just be part of the program. The creators could even alter the simulation to hide the evidence as you find it. The idea, skeptics say, is more philosophy than science. Another powerful argument against the theory comes from the sheer scale of the computation required. To simulate our entire known universe, down to every last quantum particle, would require a computer of unimaginable power. The physicist Frank Wilczek argues that there is too much wasted complexity in our universe for it to be an efficient simulation. Why would a programmer bother simulating the intricate details inside a black hole, or the quantum fizz of empty space, where no one would ever see it? For now, there is no consensus. We are left in a state of profound and exciting uncertainty, with brilliant minds on both sides of the question. Now the journey turns to you. We have traveled through the cosmos of an idea. But the most important voice in this conversation is your own. What do you think? Don't just accept what you've read. Question it. Challenge it. In the end, what does the simulation hypothesis teach us? Whether our universe is base reality or a sophisticated program, exploring the idea changes our relationship with it. It encourages a sense of cosmic humility. It reminds us that what we know is just a tiny island in a vast ocean of what we don't know. It keeps the mind open, which is the most important tool a seeker of knowledge can have. The simulation hypothesis is a gift. It's a key that unlocks a new door of perception, inviting us to step through and see our reality and ourselves in a completely new light. The universe is singing its song. We just have to learn how to listen.